But anyway, he's gonna have you some lanite. Because the samples that we get, we want you to see it at the dike, and you need to try to get you a sample there, because there's nothing like experiencing how hard that is, okay? So, and we want you to understand what a dike is, and you can certainly see it right there.
Yeah, okay, you just said it. I was trying to figure
Yeah.
out the dike is.
Yeah, we haven't got there yet.
Gotcha.
You'll learn about the features that we're gonna be seeing
Okay,
soon, we hope.
okay.
Okay, we are ready. I'm going to finish just a little bit about yesterday. I have looked at your Ceylon graphs, and tomorrow we will begin by just reviewing graphing expectations, talking about that independent, dependent variable and how you must teach children to label their axes with descriptive words and units for the graph to be self-explanatory. So we'll go through all that tomorrow, and we're going to kind of do a scattergram of all your data, putting it together so that we can see if we have a pattern from all 6 groups, okay? A predictable, what you predicted as a pattern. All right, so that's how we will begin tomorrow. But yesterday you worked on your stream table, and what we were doing is we were bridging the gap, saying that igneous rocks can be broken into smaller pieces, right? And that process is called what? Weathering. And is weathering and erosion, is it okay just to talk about weathering and erosion together as if they might be one and the same thing for children? It is not. You're going to have to clarify the difference, okay? And so I hand wrote in on my outline yesterday erosion, because I'm not going through all of chapter 3 with you. And so that's where the tar bucks cover erosion. It does have to be transported after they're small enough to be moved. And then they get dropped. And so yesterday you saw some sediments be deposited, right? And so this is called the evolution of a valley. So I don't know why oh, maybe that's a better. And maybe I could enlarge and get it a little bit clearer, but it seems to be. Anyway, this is called headward erosion, the point at which a river valley begins collecting the water that's going to flow down what's called the watershed. And so it's a very distinct V-shaped valley, right? And as you come downhill, there are changes that you would notice. This is the young part of the river. This is the old part of the river. And so headward erosion occurs this way, upstream. The stream's going to weather back in that V. Describe the water here. What would the water be like? Fast moving, very turbulent, right? A lot of force, able to move large boulders even. Talk to me about the bottom of this river. No, up here? Okay, let's just talk about this. Very fast moving, the water is very clear, right? Right. The bottom of the river would be covered with large rocks. There's not going to be any sand, there's not going to be any clay. Why not? They're all gone. They're being eroded. The water's going to be clear. You bet it is. Okay, and so as you come downstream, notice that the width of the river valley increases. The width of the river even increases. And the speed of the current begins to slow. By the time it gets here and it's making curves, it's even dropping, picking, or eroding sediment on one side of the curve and doing what on the other side, this inland side? Depositing some. And so this is called the meandering stages. When it begins to be not such gradient, not much slope, and so the river, the force of the current is less. It can't just move anything out of its way any longer because it's no longer running fast enough. And so it just kind of meanders and curves around those things it gets in its way. And so finally it reaches what's known as the mouth. It's going to empty into a larger body of water. It can be a lake, it can be a stock tank, it can be the Gulf of Mexico, right? And what is deposited under the water, usually, you saw it begin to happen on the land. That fan-shaped thing is called a
Delta.
delta, all right? And the big old things, the rocks that this river might have carried to this point, should be dropped down here in this delta in a pattern, right? What kind of things would be dropped closest to the mouth? The heaviest things, the bigger things. Because all of a sudden the water's not channeled right down this little narrow stream, but it has all these different directions to go. And so it has an overall drastic reduction on the current. And so the water can't carry it anymore. So further out would be the smaller stuff. And way off out here would be the real fine stuff. The stuff that can just be carried in suspension for great distances. So this delta is sorting those sediments out. If you noticed on your deltas, you saw the bigger gravel collect first, up at the top of the delta, the fan-shaped thing. But the little bitty fine stuff made it all the way down to the end, okay? All right,
Miss
now,
Patty, can I just clarify something on a delta? Because
yes,
it's always hardest for my fifth graders to actually even understand what a delta is.
right,
And so, what you're telling me is at the end of the river,
the mouth.
it's the, I really can't speak, I promise, I'm gonna get it out today. It's the sediment, the light sediment, and then just the lighter sediment that fans out. That's all the delta is.
It is a sorting of anything that the rivers carry. If the river is young completely, like the San Marcos River, a very young river, then you're gonna have some gravel deposited all the way down here.
Okay,
Because the slope of that river and the speed of the water and all those characteristics are more youthful
okay,
than the older rivers like the Rio Grande and the Colorado and the Brazos, okay? They have already built, they've already filled their bay, they've already filled their lagoon, they're dumping directly into the Gulf of Mexico, okay? But this is sorted sediments,
just look at sediment.
sorted sediments. And if the river's only carrying sand and clay, then you would have a fan that was sorted into the sand first and clay further out.
Can we get a copy of that?
We certainly can.
That would be very helpful to actually be able to show.
Good, I will do that for you. I'm gonna put that in the file of to-dos. Okay, here's the shocker. Because I want you to really appreciate what this weathering and erosion means to you and I. We live in Texas. We live on the Gulf Coast, right? All right, this is called the Gulf Coast, the Gulf of Mexico watershed. And so this border right here is the Rocky Mountains, the Cascade Mountains, a mountain range. This border right here is another mountain range, the Appalachians, the Smokies, right? Which one of these is active today? East Coast or West Coast? West Coast. This is an active volcanic activity area. This used to be our leading edge. We were moving this way. Our tectonic plate was moving toward a collision with other continents to make that supercontinent that we call Pangaea. But once that collision occurred, the individual plates began a different direction. So our current direction is this way. So this is our leading edge. It is active. This is our trailing edge. Are we on the leading edge or are we on the trailing edge? Trailing edge is right here. We're really on the trailing edge. All of this deposition, everything between here is being channeled right here. Massive amounts of sediments have been accumulating here for a very long period of time. right? So there is this thing in geology called isostasy. Iso in math means equal, right?
Yes.
And in science, it means equal. It means equal adjustment. So as this is weathering and eroding, the continental mass through here is getting lighter. And the Gulf of Mexico, which is receiving, a big old basin out there that is receiving sediment, has to do what in response to this part getting less,
Displace the water.
yeah. And so it isostatically adjusts, it comes up. And for every little bit that this is coming up, this is sinking. And so, all of this sediment been collecting down here for a very long time, since we left the Pangaea supercontinent, and we've been moving this away. We are a depositional coast. Is California's coast like ours? Who's been there? Tell us what the coast is like there. Lisa, right? No. Lisa, tell me. Contrast it to ours.
Really rocky.
It
looks
Right.
looks rocky on the TV. That's good enough. Does our Gulf Coast look rocky?
No, we have beaches.
You can tell when they lots of sandbars on very wide beaches, whereas California has narrow beaches.
Narrow beaches. As a matter of fact, here off the Gulf Coast, you can go out and hit sandbars for very long distances, right?
That's why the islands like Bolivar and stuff like that got completely submerged with the hurricanes, because all they are is just a gigantic sandbar that's been there forever.
Sandbar that's not forever, but it's been a long time. Ever since we left Pangaea and started.
And the coloring of their beaches is totally like opposite to ours. Like a lot of them are like black and dark grayish colors.
Right, and that's because of the weathered products are so different from ours. But the issue is, they can't wade out great distances. There's a trench off of this coast, a deep trench. It's going to get deep in a hurry. There are sea cliffs along this coastline, right? We don't experience anything like that. And so on this geologic map, you will be getting one of these. This is all coastal plain. This is all sediments, and they're mostly sediments, not rocks. They're sediments that have been deposited since this event right here. Now, I know you can't see all these little bitty black lines, but every one of these little bitty black lines is telling you that's a fault, because the Balcones Fault was a system. It wasn't just one fault line. It was a whole system of parallel faults. So what has happened with this isostatic adjustment thing is this. The central mineral region, where we're headed right here, is igneous and metamorphic rocks. This is all sediments, all of this yellow stuff. All of this green stuff is limestone. So, as the central mineral region weathers and erodes, it is adjusting our continental mass upward. And the Gulf of Mexico is doing what? Going down. And you understand that if I push up here and push down here, somewhere or another, it is going to break. So what is our evidence that we have experienced some tensional fracturing, faulting from this isostatic adjustment? The Balcones Fault System. Do all of you know that there are volcanoes in and along the Balcones Fault? There's one close to here, as a matter of fact. If you travel from Lockhart to Austin, over to your left, if you're coming from Lockhart, there is a thing out on the road sign, a historical kind of marker thing, that says Mount Kaplan. And if you look over on your horizon, you will see a volcano. It dips in the center and comes down. It's very slight, But right up in the very top of it, somebody has built a water collecting tank, huge big old thing. So you can't miss it if you're looking for it, okay?
No.
And so it was a volcano that erupted on a shallow sea floor. And so we can find some, I have not found pumice there ever in my career, but I do find scoria there. Scoria is just like pumice, except the holes are bigger, and they're interconnected with one another. So it doesn't float, but it's very definitely frothy. It is vesicular, but not small enough little holes to catch air and let it float, okay? So this tensional release form may mean that after we do this and have a big old landmass supercontinent in the middle of the Pacific, then our next direction would be back toward this. I'm sorry. Somebody was giving me the signal. Okay. Yes.
Okay, so, you know, on the other map, that one spot where we're going, does that mean that at one point that was a hotspot area? Or that
No.
that was a,
No, there was never a volcano there. Nothing ever reached the surface. It was the core of our continent.
just?
Most probably was at one time even connected to the granites that are out in Georgia and, you know, but the Mississippi River. Right. It is slowly rising due to isostatic adjustment. And as it does, weathering, what rates of weathering there,
So you have more access to it
that's right,
at that point than.
then
so
we
there-
did.
So, I guess technically then, from there, you're saying that it's connected to the one in, the stuff in Georgia. Technically, if the faults underneath that middle portion started moving at a faster rate, we could find that stuff all along there.
Yes. Okay, and so when you look at the map of Texas, now I need to do this. This room is not real easy to do this. So, do you see all of these inland bodies of water along the Texas coast? And then do you see all these nice, smooth barrier islands? What's happening here? These are major rivers. Many of these rivers empty directly into the Gulf. They no longer have a bay or a lagoon. By definition in geology, if the long axis of the body of water is perpendicular to the coastline, it's a bay. But if the long axis of the body of water is parallel with the coastline, it is a lagoon. So what's happening to the bays and lagoons along the Texas coast? They're filling in. I think we just had one of those earthquakes. And so if you were looking at the Texas coast, you would say, well, as long as we're the trailing edge of a continent that's doing that, we're going to continue to receive sediments between the Rockies and the Appalachians. We're going to fill all this in. All these rivers are going to be emptying directly into the Gulf. The barrier islands will become attached to the mainland. We will no longer have one coast, two coastlines. We will have one. Okay, until our direction shifts, changes. Okay? And so I felt like I needed to say that because some of you are going to be teaching more southward, and you know, you're not just looking at the rivers, but you're looking at what's going on your coastline. It is being deposited. Material is being deposited there. Not just a little bit, but massive amounts of it. Yes?
I have a question back to your volcano in Lockhart.
Okay.
How do you spell that so I can Google? 'Cause I drive down
It's
that
called
road.
Pilot Knob.
I drive there all the time. Where is this?
And there's a road, the sign says Lava Hill Road.
Lava Hill Road.
And it gets its-
And that's what I do. It's
Right
all
before 812. Right before 812 crosses 183.
Yes.
It'll be on your left, you'll see, it's a big hill, you can't miss it.
After the convenience store, before.
You mean at 812, where 812 intersects, you know where you would turn to go to Elroy and the F1?
Yeah.
Right before that.
You can go to the left.
Before, yeah, kind of like between that Creedmoor Road the road that goes to
I was
Creedmoor
like, I
and
drive
then
that
A
road all
12.
the time.
You look up, there's a big hill there, Pilot's not, because Pilot's picking up.
Oh, the only piece?
Thank you.
And you can drive, it's all private property, and I would not advise you to cross any property lines. But in the bar ditches, you should be able to find you some scoria, especially after a rain, after pretty good rain, you should find quite a bit. Okay, all right, I think we're ready to now talk about, since we have these sediments, we are ready to study sedimentary rocks. So I need you to take your tray, and in your notebook, on page, it's page 59 in your textbook. It is page 43 in your binder. It looks like this. I get so impatient that I put all these buttons on things, I don't know whether it's moving down or warming up. If it's blinking, what does that mean, Laura? It's warming up, okay, gotcha. All right, did everybody find a chart that says sedimentary? All right, I'm going to start sedimentary rocks with an engage. So I want you just looking and being engaged. Sedimentary. This just looks to you like a ball of what?
Rockers.
Dirt, dull, large particles or small ones?
Small.
Yeah, absolutely, it is clay. It's a clay ball. And this happened to come from Utah. And you find the clay balls, you can go out and pay to go on some property and collect you one of these. And you cut them open and they look like this. And so this is called a septaria. It was a clay ball that was rolled around on a beach, collecting together. And when clay dries, you all know it cracks open, right? Or cracks will form in it. As a matter of fact, the cracks have a very distinct geometric shape. I'll show you something in a minute. So this is now filled in. After the clay ball dried, was left on the beach, roll back and forth to collect all this mud together. It dries and it cracks open and crystals fill in. These happen to be calcite crystals. So how could I test this for you to convince you that it is calcite? A positive acid test. Now this came from right here, Martindale. A student that I had many years ago, her name Helen Monk, I can still see her now, many years ago as a matter of fact, brought this to me in my classroom. She said, "Miss Martin, would you like to have this?" And I said, "Would I ever?" Do you see that this is the calcite? And what's missing from my septaria right here in San Marcos? The clay. The clay has weathered away from mine and left the calcite little beehive-looking things. Have you ever seen one of these in Martindale? Yeah. Pretty neat.
Why is it specific to Martindale?
It used to be a beach. It was before the Balcones Fault, the coastline was right in this area. All the the border of the green area on that map that I showed you, that was pretty much outlining the coastline during the age of the dinosaurs. That's why we have so much dinosaur evidence up here on the escarpment, it's called, above the fault, okay? Blackland Prairie out here in the coastal plains is below the fault. That's all weathered material that's come from here. Can you add anything, Ms. Laura?
I think the calcite that's in there, it's important to remember that that's just calcium carbonate.
That's right.
And calcium carbonate dissolves, which is what causes all those caves. That's just dissolved calcium carbonate. And so that calcium carbonate in solution then goes into those clay balls and it crystallizes inside. And so that's how those deposits are made in the cracks.
Very good, thank you. All right, Brittany, you are going to be collecting some sedimentary rocks on your trip. This is a sedimentary rock, and can you see these white things? They're called lenses, because as we look at them in the cliff where we're gonna collect them, they kind of look like a cross cut of the lens of your eye. They're kind of thin, and then they get wider, and then they thin back out. These were little puddles, little pools, where trilobites collected and molted. That means they shed their outer skeletal to grow. And so we do find some, I've never found a perfect trilobite, but I've found pieces of trilobites in this. It's called trilobite hash. And this green sandstone, it's green because it has a very special mineral in it. And so you're going to collect some of this green stuff as a mineral sample. It's called glauconite. And it's really the waste products of all these trilobites. Oh, but you want some, okay? And of course, you must have some of this. This is limestone. And it is to all of us along the Balcones Fault so important. This is called Edwards limestone. Why is that so important to us? It filters our water. It is the aquifer. Aquifer means a rock that can hold water, or a sediment that can hold water. Doesn't have to be a rock. Ours happens to be a rock. And we don't have pure water here, but our water is of a very high quality compared to many aquifers. And it is because it is filtered through little bitty, tiny, tiny pore spaces in the limestone. And these holes are a result of acid acting on our limestone. And these can become big enough for us to walk through and go to the cave. So you're going to be going to a cave, not this 2-week time, but that's one of our Saturday things, is you're going to go through a water-made cave. You're going to be walking through some of the Edwards to do that, okay? And so you're going to want to get a piece of this for your classroom. It's called honeycombed, right?
I know a lot of my kids, when we're walking around the ribbons down in Martindale, they'll find those and they're
Yes.
thinking it's like skulls or like hip bones from coyotes. I'm like, no, it's a rock. Well, Miss Bonnie, it looks like it's a head. No, it's a rock. Just leave it.
It is a rock, and we're most gracious to have. Okay. You might. I'm gonna give you some tips because, or you're gonna wanna go back to the Living Stone place because he has a rock pile about the size, not quite as big as this room, but he really lets it pile up for us. So you will find amazing things there. Not necessarily all from here because he gets rocks in from all over the world. Okay, I want you watching. We're going to do this. Miss Laura's gonna help me. This is water. This is called a sediment tube. It's nothing but lightweight PVC. And you can purchase it in a science catalog. All this assembly right here. It has a little piece of screen wire in the bottom to keep the sediments from going down here. And so we're going to do this, and she is going to dump this mixture. Not yet though, because I want you to be looking first at what's in the mixture up there. There is some of this, and I'll pass them around, large pieces of gravel. There is some of this. What is it? Little shells, little seashells from Big Shell along the Texas coast. Neat place to go fishing. Here's some medium-sized gravel that's in the mix. Here is some sand. And here is some clay. Now watch this clay. You know how you put your hands in flour in the kitchen? Do y'all men know that? My man wouldn't know that, not at all. But some of you probably know more. I guarantee you know more than he does about the kitchen. But when I put my finger in this, how can that happen? It won't happen with the sand. Won't happen with the gravel.
So fine, it's powder,
It's so fine. The particles are very, very, very small, okay? All right, this is what's in Laura's mix. So while I get these ready to just come around on a tray for you to look at, you watch what happens in here. Can all of you see it? You want to predict?
What's gonna happen?
The heavier ones are gonna go down.
So Beatrice, you will say that again?
That's fine.
B, okay.
I'm thinking that the heavier pieces will go down first.
You think the heavier ones will end up here, down at the
And then we'll
bottom?
block it somewhere.
Okay. What's gonna happen to the, as compared to, what's gonna happen like to the clay?
Well,
It's gonna be
The
suspended.
clay is gonna absorb the
Suspended.
water and become like a solution.
So the clay is gonna float up here in the top of the
Suspended.
water
And it's gonna start,
suspended.
yeah, but it's gonna start absorbing the water.
and start settling on and filling in the little holes.
So
Gonna
then
get
in water, is
heavier.
it opposite when it's not in water? Because when you have it not in water, the lighter stuff goes to the bottom because it can fit through the cracks and crevices.
So what I hear you saying is this is not in water, so if I stood here and maybe shook this, then the smaller pieces would sink down to the bottom
Because
and
it'll
the
fit
pore
through, right,
space.
is what I thought would happen. So that
Okay.
doesn't happen in water?
Well, maybe we
Because,
can
I
see
mean,
that
it's going
happen.
through, there's a screen that will stop stuff from going through, but it's still gravitational pull, no? I don't know.
Well, we're gonna test that out. Okay, so right now it's just for you to predict what will happen and then we're gonna see what happens. Now, granted, we don't have a year to let it all happen naturally, but we're gonna see what happens in
I have a question. She has a question right here. Maybe it's what? What'd you say?
Based on the density of the particles.
Let's try.
Okay. That can absolutely affect it.
And so the density of our crust is between a 2.5 and a 2.7. Rocks material, okay? Sediments like this, mixed sediments like this. So there's not gonna be a whole lot of density difference. There is some, but it's very minimal compared to what you saw with your minerals, okay? Pure minerals. Okay.
And do you remember when we did our density investigation a while back that whether something sank or float, it was relative to the density of the medium that it's in, right? And so the density of water is 1. So Patty said that the density of all of these materials is between 2.5
5 and 2.7.
and 2.7, so all of this will eventually sink down below the water. Okay? All right, y'all ready?
I'm gonna steady it. Fast as you go.
Look at that water.
You can still see, a little bit, some of the water is still circulating up here from being disturbed.
And we're gonna let it sit here because certainly by in the morning, our water should be clear. Because everything in there is heavier, more dense than water, and it's gonna settle out. It's gonna remain in suspension for a while, but it's gonna settle out. And so, if I ask you what's the number 1 observable characteristic of igneous rocks, what would you tell me?
They're more dense than water.
What?
They're more dense than water.
Just an observable characteristic. When you look at a sample that a child brings you and says, what is this? The absolute first clue that you look for to know if it's igneous is
Texture.
crystals. some crystals. And yes, the texture would be important as the next step, you know, to guide them on how to figure out what they've got. But the number one characteristic of a water-made sedimentary rock is
Oh, the banding.
not banding, because that's a metamorphic term, but the layers. This is pretty much horizontal layers, right? And who's down here?
The ground, sir.
The gravel.
Gravel.
And pretty much right here is nothing but the sand. And the seashells are right in here, mixed in with some sand that did settle between them, because they certainly are irregular shaped and not packing together real nicely just between them. And so the spaces are filling in. But can you see this little white layer that's forming right here on top? What is that? That's the clay. So what's the number one characteristic of a water-made? Layers. Okay, on your tray, and I'm just going to tell you about these, you have what's called a sedimentator. And I'm sorry I didn't have 6, so we're going to pass one. Who didn't have a sedimentator on their tray? Y'all don't?
We don't.
Okay, I'm going to pass you one. They're kind of expensive. It would seem that you could make these, right?
Yes.
Very lightweight PVC, very similar to this, with just PVC caps that are glued on. I've had many teachers try to make them. I've tried to make them. And they work great for a while. But if I put them up over any length of time whatsoever, when I take them out to use them, if I've made them, what's happened here? I have a big old gooey growth of bacteria. And so when they made these are kind of expensive. $20 each is expensive in my book. And so they work really nice, and it finally will clear. It's got black sand in it, but if you try to make them, what are you going to have to do to those sediments?
Clean them.
You're going to have to heat it. You're going to have to get it very hot.
What if you put some bleach in the water?
If you put some bleach in the water, it's going to help, but it's still eventually not going to work for you, okay? And so if you want to do yours real quickly, get it really in motion and set it down, and then don't disturb it, and you'll see your layers, okay? Kind of share with them.
Shake it up.
Yeah, go for it.
Shake it.
Yeah, time out bottle.
Too young.
Oh, yeah. So then what are they using then?
I'm sure they no, I think they put it in a autoclave or something to get it really hot, and then put it in there and.
That's some energy.
But not all sedimentary rocks are forming underwater.
No.
The use of the layers,
Is this the
the
Richard
water.
Simmons geology class?
Right.
That's what happened.
All right, wait, we're on to something very big here. She said, but not all sedimentary rocks form underwater. So I want you to look at your tray. And I want you, has everybody seen these sediments? Did this tray come by everybody?
Yes.
Okay, turn your tray up, your white tray, so that you can look at A, B, C. You're missing D. I'll show you why in just a minute. Laura's going to hold up the gravel. I want you to find a sedimentary rock with gravel in it. Find it in your tray.
Wait, what kind? Large gravel or?
It doesn't matter. I think everybody has large except one person has a medium gravel. Doesn't matter what size it is. If you see rocks in it, it's the same sedimentary rock. All right, did everybody find it?
Yes.
So what layer, what rock was it? A, B, C, D, what?
A.
All right, and so, look at your chart and tell me what the name of that sedimentary rock is if it is made of gravel. It is called conglomerate. So look right here, because cameras comment not all sedimentary rocks make layers in water. So do you see this side of the chart?
Yes.
This word says detrital. Detrital. It is sometimes called in some books plastic sedimentary rocks. The individual particles that settle out in the layer are called clasts or detritus. Debris from bigger rocks. Weathered, smaller rocks from things that are bigger, okay?
Right,
So-
like Patty?
Yes.
Is there another type of rock that uses the word clastic? Like, isn't there an igneous term that, like pyroclastic?
Pyroclastic, yes.
Like volcanoes erupt and there's pyroclastic
Part
results?
of residue, debris that shot out, yes. Okay, can you find the sand? Find me a rock in your tray. Feel it. Rub your fingers over it. Do you find anything that seems to be made of sand? Look at your chart. What do they call it in geology? If it's layered out of water as detritus or clasts, what's it called? Sandstone. Sandstone. So next, find me a sedimentary rock made of clay. That little bitty fine white stuff that's just now settling out in a big old white layer back there. Have you found it? You're looking for clay, settling out in little bitty tiny thin layers. Alright, some of you are looking at H. Watch. I'm going to give you a hint about H. Watch. It's called chalk. Those of you who live in Austin, it's called the Austin chalk. Very common over there. It gives a positive acid test. Do you see it on this side of this chart?
No.
No, because it is not classified as a detrital or clastic sedimentary rock. Are you understanding? You might want to add this. This is only particle size. You're only going to be considering particle size by looking at that half of a sedimentary chart. Those are the ones that settle out of water in layers. Now, find me one that was made of those seashells back there. Which one is the clay? Isn't C? C should be your clay.
C is the clay?
Yes. Use your chart. What's it called?
That's called siltstone.
It is called siltstone, but I'm going to ask you to do this. Your textbook calls it shale. Circle that word shale. Do not ask elementary students to distinguish between silt and mud. They're both microscopic measurements.
So it's clay, silicone,
Shale
shale?
is what I only would use with elementary students. It is mud or clay, the finest of particles. Don't try to subdivide it anymore. Just call it all clay or mud. It's okay if you want to call it mud.
Why wouldn't you just introduce that?
Introduce what?
The words, like what is it?
That's what I'm saying it shouldn't. Because it's a microscopic difference. Are they going to be able to look at shale and siltstone and tell a difference? And the answer is no. They're microscopic differences in the particle size. That's right. You're just talking about all of this together. Do you see it's all very fine? 1/16 to 1/256 of a millimeter. You got to have a microscope to measure it. And so this one is even finer, okay? And so just put them all together and call them mud or clay, whatever your wishes are. I prefer the word clay because that is specifically what shale is made of, is clay. Okay?
Mud or clay could be.
Mud or clay?
The kids are gonna like to say mud, but to make sense in terms of the rocks that it produces, I would use clay. That's my preference because it fits with the shale.
This one is shale.
That's right. That is shale. All right, did you find me one that looks like a granola bar? Look at it closely. What's that granola stuff in there? Why isn't that over here on this side? It's not detrital.
Still water.
It would give you a massively positive acid test. You put a drop of acid on that, it's gonna fizz and bubble like crazy. Okay? All right, but find it over here. Find that seashell one over here.
So you're gonna see, and when you go out and see cross-sections, you see one of them.
It could be either coquina or it could be fossiliferous limestone. It happens to be this. Do you see my letters on here? I am telling you what compartment.
Well, and it says the main difference in description and texture is loosely cemented and cemented.
Yes.
So this is coming off as basically feedback.
Yeah,
So that's
and you
why
can
it's
look,
coquina.
that's right. This is found, this coquina is found in Florida, very loosely packed. It has not been compacted. It hasn't even really been lithified. It hasn't been glued very tightly together. And so because of its unusualness, they give it this name.
It's just kind of.
All right, let's go down the list now. Everybody understands exactly what Tamara was asking. Not all sedimentary rocks form in layers. They all form in water. But those that are going to settle out into the layers are going to be made of detritus, clasts, smaller pieces of bigger rocks, sorted by water, right? The water sorted them. Would wind sort them?
No, yes.
The clay.
Can wind pick up gravel and sand and clay
Yeah.
simultaneously all together? Yes, if it's blowing hard enough, right? But then when it begins to die down, who's going to drop out first?
The heavier pieces.
The heavier things, and who would be next? The lighter, and the clay would make it the furthest distance, right? Could continue to be carried by a gently blowing breeze. So wind can sort sediments too. But because of the preponderance of water on this earth, most of our sedimentary rocks are made
Well, and let me see your picture.
from water
Wind is not constant. I mean, well, in
That's
an
right.
area.
in an area.
Because but water is fairly constant.
That's right.
Movement, so it would have a bigger movement.
Overall effect. Okay, let's do this side. The other side are called the chemical sedimentary rocks. Everything over here is made from stuff that can be dissolved. Now, here is that discrepancy between physical and chemical change and what the geologist calls physical chemical change with rocks. These are called chemical sedimentary rocks. Is dissolving a physical or chemical change
Chemical.
in chemistry?
Chemical.
It's a physical change. And boy, you do have a chore to teach that to children, right? That when water evaporates, it's still H2O, just molecules moving faster, still the same stuff. We can get it right back by cooling it off. And so, but here, because dissolving weakens the mixture of minerals in a rock, it loosens them and allows the overall rock to be chemically changed because it falls apart. Some things leave because they're dissolved in water or dissolved by acid or, any of those things in the environment that can cause a chemical change. So these are all things that have dissolved. And how do we get them back?
Dry enough,
What?
dry enough.
Dry them out. We have to let the water evaporate. And so these right here are called the evaporites. Look at them. They are J, K, and L in your box. I could have given you TB stone. I could have given, oh, well, here's the calcite already up here. Whoa, can I not read that? Can y'all read that? I guess you're looking at your chart, but it, I don't think I can get it big enough for me to read. Okay, there is your, look, here's your calcite right here. CaCO3. That means everything here could be verified by what test? This is all positive acid. So here's that chalk. You mean to tell me that chalk gives a positive acid test? It does. It is made from diatoms, little bitty microscopic remains of life. Okay? All right, so looking at, you don't have a D. Here's one. Here's my crystalline calcite. And I had a choice of breaking this sucker up, or, so you had a piece to look at, or keeping this on my bookcase. Okay, so I did. I was selfish, okay? Sorry. This is crystalline. Has anybody ever seen this in nature before? In a cave. Yeah. Inside some geodes, you bet. There are sedimentary geodes that have some of this in them. Like this septaria was calcite. Okay?
And you can see the open space in here is just a teeny tiny version of that.
But you're saying that's sedimentary.
This is sedimentary too.
But
The crystal,
they're confusing me. You see crystals all
crystals are
over.
big.
But these are evaporated calcite
How do you know
crystals.
the difference?
Acid
Acid
test.
test.
Okay, so I'm just saying if one of my fifth graders comes to me, I would, oh, that's it,
Well, we
yes.
don't,
Because I don't have acid around it. That's what I'm saying.
Could you have vinegar?
Yeah.
Vinegar is an acid.
Okay.
You get you a proper bottle of vinegar.
Okay.
You drop that on there, it'll fizz.
Yes,
But it
ma'am.
wouldn't on crystals, of course.
It wouldn't on igneous crystals, it won't on the silicates. This has CO3 in it, a CO3 radical. When you put that acid on there, it's gonna free carbon dioxide to come bubbling off. Here, we'll do an acid test.
And something else that you can do also that can test that, I mean, I wouldn't do it with something pretty like that, but to illustrate how the calcium carbonate will dissolve and then recrystallize in something like that is you can take a calcium carbonate rich limestone or something that's very calcium carbonate rich and put it in a cup of vinegar and let it just sit there and maybe suspend a string or something, and as the vinegar evaporates, the calcium carbonate crystals, I mean, it will dissolve it and then the vinegar evaporates and the crystals will reform. The calcite crystals will reform.
do like rock candy and
Yes.
Would also be good to put rock or
Go, big go.
I'm gonna do it on the side that's not so pretty.
I mean, you can also make crystal thing with salt water, with sugar water, and maybe make one of those, you know, those sticks with the sugar crystals that they use, those sugar crystal things. Yeah, the rock candy.
Can you see? I'm gonna do an acid test for you. I wanna ask you though, where else you see these? Do you know about those icicles in caves? You're gonna be seeing some of those when we visit natural bridge caverns. Stalagmites, soda straws, ribbons, stalactites and stalagmites. What mineral are they made of? Calcite. They are crystalline calcite. So this could have been a cave formation, or it could have made, if it was dripping from a point, you know, as a drip, It'll make a stalactite, they hang tight against the ceiling, and a stalagmite might someday grow tall enough to reach the ceiling. And that's the way you teach children the difference. My dropper bottle is not working too good, so I hope you can see this. I don't exactly know where to put it so you can see it the best, but can you see it fizzing?
Oh, yeah.
It's like, rockside. Oh.
This, some of you are going to be lucky enough to find a calcite rose like this on our field trip. These are called gypsum desert roses. I personally dug for this on the Arabian Gulf. Saudi Arabia, just across the way from where we were digging in the sand dunes of the Sahara Desert. This is gypsum, and so it's hot in the Sahara Desert, and that water is rich in gypsum. Here's gypsum on your chart. Look down. It's in your, can't even read this chart. Yeah, rock gypsum, and it is J in your box. Yeah, it is on page 59 in your textbook without all the color graphics interfering with your ability to read it. Do you think this will fizz with acid?
No.
No, look at your chart, at what's in gypsum.
It doesn't have carbon.
Gypsum.
Carbonate.
This is sand grains that have been welded together by this.
Nope, next one. That gypsum has.
They're liquefied. They're gluing it together. Okay, I'm going to tell you about this. We dug holes. I could have brought home a piece as big as this room because the further you dig, and it's all one huge piece, but they do break off. They're rather fragile. But I had just finished teaching a mixed group, and so they were coming back for their Saturdays, and I was intent on bringing each one of them. And plus, Dr. West and the whole crew had to have a desert rose because I got to go visit my grandchildren in the Middle East. And so they took me crystal digging, and it was quite an adventure. But imagine me, I had that this blue container up here on my thing. It's how I brought them home from Doha, Qatar. And I had each one of them carefully wrapped in toilet paper. So I come to customs heading home, and I'm going to carry this thing, right? They're not going to put my crystals on that conveyor belt. I'm getting them home, as is, perfect, every one of them, hand selected, wrapped in toilet paper. I get to customs, and they're, I'm in an Islamic country. I don't speak their language, and they don't speak mine, and they are wanting to know what I have, and I'm going, rocks. I don't know how to tell them what I have, but they're talking away, and all of it, they're calling people over, they're undoing my toilet paper everywhere and looking, and finally they call somebody over, and he kind of looks at me and smiles a little bit, and I think, oh, okay, maybe I'm going to get home with these. And so he said, so I grabbed my toilet paper, and I grabbed my crystals, and I quickly put them in that tub and went to the ladies' room and sat in the stall and rewrapped. I wish I had all of them to give you one. I don't. I guess I need to go back, but
Field trip?
anyway. Huh?
Field trip?
To Saudi
Yeah,
Arabia.
ask Dr. West, okay?
Put it in the grant.
Will this fizz with acid, I'm asking you? Have you looked at its chemical composition?
Yes.
Will not.
Does it have CO3 in it? That's the only way it's going to give a positive acid test. It does not. This will not react with acid. You're going to find, some of you are going to find, remember it's evaporate. This is an evaporation process in the sand. And so it feels gritty, but underneath here is nothing but gypsum, just like your piece of gypsum there. Very clear. This sheetrock in this room, you all know about this sheetrock? There's some white stuff, right? There's paper and some white chalky stuff and paper, and it's called gypsum board, technically. So what's that white stuff in between that cardboard? Gypsum. And there's a US gypsum plant just the other side of New Braunfels. Have you seen it over there? The hills are gone. If you're traveling towards San Antonio on I-35, past New Braunfels, you see all those hills that have been cut into over there? It's called the US gypsum plant. You need to drive around that thing and pick you up some samples of gypsum.
One of my students, they live out in Leland, they have a gypsum, I don't know, they call it the diamond mine, but they've got
A vein.
gypsum, yeah.
Yes, there's one right here, you know where the salt grass is? You go up that hill,
To the headwaters.
into that clay area as you go up to Rogers Hill. On the left, there's some veins of gypsum. Yeah.
They brought me, they're like, Miss Bonnie, they brought me a diamond. I was like, well, thank you.
And we may find some. It's been hot and dry. Some of you will find some calcite roses. Yours will or will not fizz with acid.
Well, not.
They will. They won't be this big. They'll be about like this, but they're beautiful. They're sparkly. They look like a little flower. Open rose bud almost that you will find. You'll find them mostly when we go to Cross Mountain. Okay? All right, and so we are almost through with sedimentaries. Let's go on down the row and find the others on your chart, just to be sure. Travertine, would you look at E? When we go in the cave, when we go to Natural Bridge Cavern, it's already scheduled for a Saturday trip, you will see a lot of travertine. Where the water drips into that cave and makes puddles, it builds those little dams around the puddle of water. That's called travertine. Look at your piece. Have you ever seen it around a swimming pool or maybe on a patio floor? Yeah. Do you think it's real durable?
Yeah.
Yeah.
Travertine. What's it made of? Yeah, it's got CO3 in it, and so you use a lot of chemicals in your swimming pools, right? Would it readily stain? Will it easily weather, especially chemically weather? Yeah. So it would not, most of the time they fill in the empty holes in it just to reduce the surface area. So it's not quite so susceptible to weathering, but it's going to weather. Okay, it is a limestone, a soft limestone. All right, and on down, we looked at coquina. You have a piece of fossiliferous limestone in G. Would you look at it and see the fossils, please? Can you see some shell fossils in there? Yep. But the telltale, absolute best way to test it is what? With the acid test. If you think you see fossils in it, you do that acid test. Because if it is there, if those fossils are in there, you're going to get a positive acid test.
Which one is, this is how do you say that?
Oh, coquina? Oh yeah, coquina's going to give you a good acid test. These are my samples, so I can do this. You're going to have unacidified samples for yours. All right, everybody watch. It's going to happen so fast, you best be looking.
Oh, can't see.
It was too high.
Oh, sorry.
Oh, wow.
Super cool.
Here is fossiliferous. I'm going to keep these out of y'all's boxes, okay? Okay? All right. So watch it. Look, didn't get any. My dropper doesn't work too good.
It's just like hydroperoxide. So cool.
Okay?
Now, when you said like we could use like vinegar, what acid are you actually?
I'm using 10% hydrochloric. We will have this on the field trip with us, okay?
Okay.
Where do I get that?
We order it from a scientific catalog. I
You
think
can order it from, you can order it online, Flynn, I mean, any of the
right, Sergeant
Because the
Welch.
vinegar doesn't work near, I mean, it works.
No.
I just don't see that it works as well.
But you gotta be careful with this, kids.
Yeah.
This will burn your hands.
Yeah. Right.
Google and apply acid.
I don't think it would follow Sean's advice. I'll bring you some tomorrow. Alright, watch, I told you I'd bring this. Do you know what this is?
Heating element?
What's that white stuff on there?
Calcium.
So what do you think is gonna happen when I put this acid on here?
Clean it. Took one out of my one the other day.
I mean, it's cleaned up now
That's
compared
why
to
you
what,
can put like vinegar in your coffee pot.
yeah, put vinegar in your coffee
Dishwasher,
pot.
do your washer cleaner.
Can you see it reacting? Just a little, if I had it turned sideways, maybe you could see it on the side. Let me put it down here where it's softer looking than it.
Oh, now you can see it, yeah.
Okay?
Just on a side note, one of my own children did a science fair experiment on acids and teeth. You know, your teeth are made up of the mineral apatite. And took teeth and put them in different acids like hydrochloric acid and CLR, Coke, Dr. Pepper. We had a whole different array and time, how long it took for those acids to dissolve the apatite in your teeth. And your teeth actually dissolve in Coke over a couple of days.
Don't drink it, it's evil.
That's cool.
It's not
Where'd
like
you
it's
go,
toxic.
I still drink my one.
Where'd you get the teeth?
Just rinse them out.
Brimstone, got it.
Miss,
Alright,
where did you get the teeth?
watch this.
Where'd
I,
you get the teeth?
They pulled
Oh.
would you look at I, please? It is called chert if it's a light color. If it's a dark color, it's called flint. They are both made of quartz. They are a sedimentary deposit of silica. Silica dissolves out of feldspar pretty readily. And then it can be carried in solution, and it finally then out here on the Blackland Prairie settles out as an evaporite. And so we find a lot of flint out here. You are going to be going to Cross Mountain, and there's just going to be chert laying everywhere. It's beautiful. Every color you can imagine of chert. You're going to find yellow, green, pink, a bluish color, snow white, but it will all show that conchoidal fracture. And the Indians then use that for their tools because it breaks it to make sharp edges. Okay, it's like a glass, a silica glass, but it is a sedimentary deposit.
So then is this a mixture of flint and chert since we've got light?
It probably is all too light to be, you know, it's a very subjective thing.
Because like
Yeah.
this to me is dark.
Is dark. And most flint is a real rich, deep brown color, reddish brown even and black. And so you will definitely be collecting chert. All right, so coming on down the list, we did rock gypsum. You see your halite, don't you? It is an evaporite. And your last one, what is it? Pick it up. Tell me, dense? Not very dense. Not very dense at all. So I'm just going to tell you some things about coal for now. Coal is a fossil fuel. This is considered to be bituminous coal. You will be going to the dinosaur tracks on our field trip on Thursday, and you are going to see a seam of lignite coal. Lignite coal is the lowest grade of coal. By low grade, it means that you would have to burn a whole lot of it to get much bang for your buck. Yeah, much energy from it, because it is full of ash, it is full of water that hasn't been compacted enough, but it formed in a shallow, fresh water swamp. That's the environment that's necessary because it's made of plant material. That is mostly coal made from plants falling into fresh water, and it has to be a perpetual thing of water so the plants don't rot, they don't get dry, they fall into the water, rotting, more fall on top, and they're not exposed to the air, and so they compact. And they are finally lithified due to compaction and some sticking together to form higher grades of coal. And of course, once you get the metamorphism in on it, then you've got the highest grade of coal. We don't have any of that in Texas. Okay, that's all over on the Appalachian Mountains. Okay?
Is that anthracite you're talking about?
Anthracite coal, that's correct. We call it black gold. You'll see that in your metamorphic rock press.
So when you talk about peat, you don't get anything from the peat? Is that what you're?
Peat is
It's just
the
when it
plants
starts?
break apart.
Okay.
I was hoping to do a coal sequence with you, and I start out with peat. We call it peat moss. You probably put it in your gardens or your plants or whatever. That's, if you look at it close, it's just little pieces of stems and leaves and, vegetative material. And then that gets compacted to make lignite. Further compaction, over time, more stuff falling into the swamp on top, and it becomes bituminous coal. But then once the metamorphism comes in, the heat, the pressure, and the chemical changes, then it turns it into anthracite. That's almost pure carbon.
So when you teach that, you talk about the metamorphism. You don't,
I do I have an egg carton of peat. I start out with a fern frond.
Okay.
I just clip a piece. I'll bring the boxes at least, even if we don't have time to do it, okay? Because if you're teaching school along this Balcones Fault, you're probably going to have some parents who work for one of these coal companies out here. And you're going to be expected to know some things about coal and understand it, what they know and don't know. And so, it's a fossil fuel, so there's some risk in burning it. But over 90% of our electricity right now is coming from the burning of coal. And we have a supply that could see us, hundreds of years to the future. We don't have that much supply. Now, we're better off today in terms of the oil, which is from animals because of all the slant drilling that's going on right here in Texas. And you know what a boom that's made. Our roads are torn up from all the trucks that are coming and going and the jobs that you can go down there and sit in a little bitty house and just check in the trucks that are coming in, and you can make twice what teachers make. It's just amazing to me. I mean, you don't have to have any further education, nothing. You just sit there in that little house and keep a record of every truck that comes in and leaves. Air-conditioned little hut.
Well, sign me up.
All you gotta do is go find a trailer house to live in, because there's not living conditions for all the people that are down there now.
Stay home with
Those of you from down there, you know. You know what y'all schools are gonna be like down there?
I do know, I worked down there. It's awful.
Yeah. Your class is gonna get bigger and bigger and bigger. But your school district should be getting more and more and more and more money to deal with that too.
Well, if they're renters, no, or if they just kind of.
No, but those companies are paying big time. All right, wait a minute. Are you feeling okay about water-made rocks? All right, let's move to a break. Could I have you back here at 5 minutes? It's really 9:45.
Yes, ma'am.
So can you be back here at 5 till 11? Till 10?
Till 11.
Till 10, till 10. We're gonna do metamorphic rocks, okay?
The new 6.
Y'all are such fun.
She wanted
What's I had trouble with this yesterday.
You gonna bring you another one?
I don't know. So she is, she's not gonna
Are you okay?
Misty. She's
Got up a little late
do
today.
it.
I got it.
So I told her she would really enjoy it. She said, I said, I've got it all.
Whether Patty wants to
No
or
worries.
not. Where do I
Yeah,
buy that?
she was like, I really like your tweets. They're good.
Like I have
And they only have one car. So.
No, with the whole thing.
Okay, well, we're doing kids tomorrow, so after you see what you have, then I'll get
So I want,
New one.
okay. That's why you should watch that come. Yeah,
Somebody has to look
that's
at it.
really cool.
Something else.
Give me a picture that she takes some of the cemetery rock.
My wife and I went to Paris last summer and we went there. The way we.
These are actually, I like these. These are pretty cool. How is that?
Yeah,
Where are you
that's
going,
pretty
Hannah?
good.
With berries? Different, two different berries, right?
Right now,
We got some reflection going on. You can see that.
Did you have what, blueberries and raspberries? And it's pretty good flavor? Awesome.
Squeeze it in and you
You know what I am?
It came from Montgomery Ward, so it
In a little bit.
WARDS.
break it a little
I just
bit.
put it, yeah.
It's gotta push down a little bit. I think that would be good with the straw, just.
And so it is a mountain, but
You're getting your fruits and stuff like that. Doing that right there.
And I think we need that, maybe with the,
Oh,
yeah, even if you do that with the lemon, because those seeds are big enough for the seeds to come out.
my goodness.
So it's a little bit if we squished it up.
And it's not-
Let me push it up.
Yes, I use one of those filters.
All right, cool, okay, what's up? Thank you.
I wanted to like one of those
Okay.
time travel photos.
Yes, Mom. I just need to stand, because my behind starts hurting from sitting and my legs.
I looked at
After
Lucid.
You know what?
I don't know, but look how clear it already is. You can still see some of the stuff floating around.
It's like after a rain.
Yeah. Well, you know what this reminds me of? When I was younger, we lived out in the middle of nowhere, and we had big old ditches. And when we have really hard rain, it was really dark like it was before. But then as it started to, when the sun started coming out, it started to come, it would get like this. Where you could actually see the tadpoles and everything. And I used to pet buckets of tadpoles in water like that. That's what that reminds me of. I mean, it's just like,